Hello all, I'm Dr. Rizvi and this is another lecture on Mohr circle, and in this lecture we will solve the numerical on Mohr circle. Let us start with the video. Here you can see that a numerical is being given on Mohr circle, and it states that the principal stress at a point across two perpendicular planes are 75 meganewton per meter square and 35 meganewton per meter square. Both are tensile in nature. We have to find out the normal, the tangential stress, the resultant stress, and the obliquity. And on a plane that is at 20 degree with the major principal plane. So all the things are given in the numerical. To start with the numerical, we will make the figure of the element that is subjected to the stresses. So we'll make a box like this, which is carrying two perpendicular stresses. They both are tensile in nature. One is 75 meganewton per meter square and the other one is 35 meganewton per meter square. The question says that we have to find the normal, tangential and resultant stress and its obliquity on a plane at an angle of 20 degree with the major principal plane. The major principal plane is that plane that carries major principal stress. And here you can see that major principal stress is 75 meganewton per meter square. So this will be the plane on which we have to find the normal, tangential and resultant stress, and it is at an angle of 20 degree from the major principal plane. We have to find sigma n, sigma t and sigma r, and also angle phi. For this we will first assume the scale. We'll do the scaling. Here we are doing it with the digitizing pad. On copy you will use scale and protractor and compass to draw the Mohr circle. First of all we will assume our scale and let 1 centimeter equals to 10 meganewton per meter square. Therefore, sigma x, stress along x-axis, it is 75 meganewton, so it will be 7.5 centimeter, and sigma y will be equals to 3.5 centimeter, as it is 35 meganewton per meter square. The angles are represented twice on the Mohr circle, so 2 theta will be 40 degree, that will be represented on the Mohr circle. So now let us draw the Mohr circle. We'll draw the y-axis, we'll draw the x-axis. Since both the stresses are tensile in nature, so they both will be marked on positive x-axis. 1, 2, 3, 4, 5, 6, 7. Like this we'll do the marking, and we will mark point A such that OA, sorry, it is 7.5, so it will be near about this point will be A. OA will be equals to sigma x equals to 7.5 centimeter, and OB will be equals to sigma y equals to 3.5. So 1, 2, 3 and 3.5. This point will be point B. Here you can see that we have marked point A and B on x-axis as the representation of sigma x and sigma y. Now we will find the center of B and A. It will lie at 5.5, because we'll do the summation of sigma x and sigma y and we'll divide it by 2. This will be the center. So sigma x plus sigma y upon 2 will be 5.5. So 1, 2, 3, 4, 5.5. This will be the point. We'll mark it as C. With C as center and CA as radius, we will use the compass and we will make a circle here. This will be the Mohr circle for the given question. And now, since we have to find out the value of normal, tangential and resultant stress, and the oblique plane is at 20 degree with the major principal plane, so from C we will use the protector and we will mark 40 degree, and we will extend this line such that it meet the Mohr circle at point D. This is 40 degree, and from D we will drop a perpendicular on x-axis and we will mark this point as E. We will join point O and D. Now, since we have studied all the cases, we know that this distance from D to E, this is sigma T or the tangential stress. This distance from O to E is the normal stress, and this distance from O to D is the resultant stress. We will use the scale and we will measure this in centimeter and we will multiply it by 10 so that we can find out the final value of normal, tangential and resultant stress. This angle DOE, is the angle of obliquity phi. We will measure it using a protector and we will finally write the value of phi using the protector. This is how we solve the numericals on Mohr circle. Thanks for watching the video. Thank you.